I will be presenting VP6, which is trials and demos work package of this Tivit Internet of Things program. I'm presenting these slides, which have been made by me and most of all the colleagues leading the tasks, and so I will give you a brief overview of the 6 tasks, or actually 5 tasks, because Mikael is presenting one task in more detail after the coffee break. So work package 6 links research and development into innovation in applications, and also in work package 6 we have demos, the purpose of which is obviously demonstrate the results to general public and the stakeholders. So as Vili and Sasu pointed out earlier, we have 4 more or less technical work packages. Then the 5th is ecosystems, and the work package 6 trials and demos is kind of it gives requirements to the technical work packages, and it takes the technical solutions, tries to integrate them and show them in trials, and then give feedback to the other work packages. That's the kind of rationale for this work package 6. We have this year 6 tasks, 6 trials. Some of them, or most of them, are the same as last year, but there are actually 3 new ones. So we can say that half of them are new ones. The volume is some 220 person months, so it's a big work package, and I will go briefly through tasks 6.2 until 6.6 with 1 slide each, and you can also go into or have more detailed information about the results in our demo booth, booth number 1, which today is showing the things Jyrki was describing just now, and tomorrow there will be their corporation's demo related to task 6.1, and on Wednesday we will have Internet of Things for Intelligent Traffic System, that's 6.4 here. So we have different demos on different days, so you should visit, if you're interested, this booth today, tomorrow and Wednesday. Okay, going to these tasks. 6.2 is secure and automatic IoT service provisioning. So this task deals with how to provide IoT-based services for people and small enterprises easily. And the special target group is elderly people living at rural areas and living by themselves, and how ICT and IoT technologies can help them. And we have identified and are demonstrating and piloting the following aspects: safety and security, so sensors monitoring the senior person living at home, how she or he is doing, is she active or not, and so on. And then emergency services are called based on the need. Medical services, live video consultation with doctor, nurse, or other medical person, without moving from her or his house. And of course then entertainment, infotainment, activating these elderly people. And currently we have selected sensors at home, and they send data to service platform, and they are managed in the cloud, and services are to be tested on this. So the purpose is to improve quality of living for senior citizens, and this is driven by Mikkelin Puhelin MPY. The second application area is networking in underground mines, so how to get sensor data and other data out of the mine, which is very challenging for communications aspect. The solution is this kind of ad hoc network where moving stations like vehicles and persons or smart objects carried by persons can carry the message or the data and then send it forward. And this has been experimented in the Outokumpu Kemi chromium mine. So this opportunistic routers means that the data is sent or carried actually by moving the platform, the drilling machine or truck or something like that. So the benefits, of course, are the extending the reach of networks in extreme locations, which is not coverable by other means, and providing backup connectivity in the case of infrastructure failures. The third topic is traffic information service, which was also mentioned already in Sasu's talk. So we have a corridor, this kind of smart traffic corridor in Tampere, city of Tampere, and there buses and taxis act as kind of moving sensors which convey information about friction, temperature, speed, vehicle behavior, and environmental data. And this can be, of course, useful for other vehicles moving in the same area. Currently we have the experimental system, and buses and taxis are providing the information, and next we are analyzing the collected data, developing interfaces, and adding third-party information and applying or accommodating to standards. The main companies driving this are Mobisoft, Mattersoft, and also Renesas and Refecor are involved, and VTT and Tampere University of Technology are the other partners. Smart battery management relates mainly to batteries, for example, in base stations, how to manage them in varying and difficult conditions, and how to monitor them, how to visualize the situation to the users, the company, for example, the teleoperator having these batteries or operating the systems using these batteries. And the early tests are starting, so this is one of the pilots starting this year. And the benefits will be safer batteries and devices, and also reducing cost of managing this system, and more secure or more reliable operation. And the final task is that we have, or Ericsson has, this device connection platform, and we would like to be able to, or like to see what kind of applications could be built on this application platform, and what kind of limitations and good points and development needs there are. And this task is implemented so that students are given opportunity to develop applications on top of this platform, and test it, experiment, and give feedback and produce results on that. So as you see, we have a variety of these trials and demos in this work package, and some of these will continue next year, but we are also open for new trials and demonstrations here, as already mentioned by Willy and Sasu. Thank you. I think if there's questions, I can answer, but otherwise we will have coffee.